Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. How are you doing? Today we are going to finish doing chapter number 1. And last time we have discussed the components of the database management system environment. We said there are 5 main components, and it can be categorized as 2 main categories with a bridge in between. So machine and human. And we can say that the machine means or contains hardware, software, and human means people and procedures. And what we can see, the most important component in the database management system environment is data, and can be like a bridge between both categories. Okay, so we have stopped here. We have discussed the hardware, software, and we talked about yes, data, procedures, and now we stopped. Now we are going to finish talking about or discussing about the last element, which is people. Okay, we talked about data administrator, and we said it can be database administrator, or the role of data administrator can be merged with role of database administrator. Okay, in some organizations. And then we talked about the logical database designer, or a logical database designer who is concerned identifying or considering what data to be represented in the database. What, okay, considering what. So conceptual and logical design, put this in your mind. They are aware of what data to be represented in the database. So what? Okay, answering the question, what data to be represented. So conceptual is the first stage. Conceptual database design is the first stage of building up a database or designing a database. So what data to be represented? Identifying the entities, the attributes, all right? And the constraint, the relationship between entities. So these are things to be considered the conceptual design. So attributes, entities, relationships, plus constraints. And we talk about constraints. We said it's like restrictions. It can be applied over the data. For example, we can restrict the number of accepted records. As an example here, a member of staff cannot manage more than 100 properties. This is a sort of constraint. Okay, this is some, or these are some examples here. All right. And yeah, we mentioned the conceptual database design. It's the first stage of designing the database, and it can be identifying, as we said, as we mentioned here, the entities, relationships, and attributes, and so on. And it's independent of implementation, like targeted database management system, application, programming language, physical consideration. These are not considered in conceptual design because it's independent here. Okay, so focus on that. Only what, let me just write this once again, considering what data to be, okay, what data to be represented. Got the point? What data to be represented in the database. Okay, so this is, let me just change the color here. All right. So answering this question here, What is the difference between conceptual database design and the logical database design? The logical database design is the process, the second stage of designing the database. It's like considering same what data to be represented, entities, relationship, but how to map it with the database structure. Okay, so it will be mapped in the logical design. From the conceptual design, we are having a conceptual database design. Then in the logical, we can map it with the database structure in order to implement it. All right. So in these two stages, these are linked together. In the conceptual, we identify the elements, the entities, relationships, constraints, and attributes. In the logical database design, we are deciding about the mapping. Like we have different types here. How we are going to map it with the database structure in order to implement it or implement a database system. So, for example, we have relational using relations. And relations, I have mentioned this before. It's like each relation, it's like a table. Here, let me just draw it properly. Okay, it's like a table, which is called relations. So we can put these entities, which were identified in the conceptual database design. We can put it in a table or relation. That is the relational model or relational logical design. And we have something else we call network, hierarchical, object oriented. So these are just examples. We are going to mention or talk about them in the next few chapter slides. All right. So this is the main difference between logical and conceptual and logical, but it's still in the same stage, logical database design. Okay. Still in the same main stage. All right. Now let's talk about physical database designer. What is the main role of physical database designer? We said in the logical database designer, he is responsible of identifying what data to be represented, right? How about the physical? Who can tell? So what data to be represented is decided in the logical database design by the logical database designer. Like what entities, what relationships, what attributes. How about the physical database designer? Which question is going to be answered here? Here we have a hint. How? All right. So which question to be answered here? How the data will be represented. Okay. In other words, how it will be implemented, how the system will be implemented. All right. So how data will be represented. Okay, so this question will be answered in this stage, the physical. Okay, physical database design. So the physical database designer is responsible of deciding how the data will be represented, involving mapping the logical database design to set of tables and integrity constraints, selecting the structures and access methods required. All right. And also, in addition to designing security measures. Okay, so everything about element implementation, the system implementation will be considered in this stage. Okay. All right. It is said here that in the physical database design, it depends on what we mentioned something about the targeted database management system, the implementation information. So we said in the conceptual or the logical database design, okay, when we decide what data to be represented, okay, it's independent of implementation information like targeted database management system, unlike the physical database design. So in the physical database design, it's dependent or depends on the targeted database management system. Okay, so it matters. We need to consider the database management system, all right, in order to decide the implementation mechanism. So the designer must be aware of the functionality, aware which database management system are going to be used, and also understanding the advantages and disadvantages of each alternative for particular implementation. So he must be understanding advantages and disadvantages, and he must be capable of selecting suitable storage strategy. Okay, so he must be aware of all these information. So as a summary, conceptual and logical are concerned with what's data to be represented, while physical database design is concerned with how to be represented. Okay, as we said. Any question so far? We are going to discuss about the logical database and physical database in full details later on, inshallah. All right, so this was information about a database, logical and physical designers. Now, application developer is another role or another, let's say, type of people who are considered here in the components of database management system environment. So he's responsible of developing the application program, all right, which provides a channel of interaction between the user and the database management system. So it can be embedded with the database management system. So it's concerned with the end user. All right, and it can be written in as we mentioned before, 3 generation language or 4th generation language. All right. So they are the application developer, basically they are aware of the user requirement. So whatever required by the user, they are having their own analysis or system analysis and user requirements and system specifications. So based on that information, they can develop or design the application program. Okay, so it's related to receiving data, inserting, updating, and deleting data. Whatever required, it can be developed within the application program. Like what? As an example, what is the example? Can you give me example? Here, and the 4th generation language, what you are using in the practical session? SQL, right? Yes, Ali, thank you. So, exactly, Qasim. So you are using SQL as an interface between that interface that interacts with database management system along with the database. Okay, as people also we can count end users or clients as a main or yeah, it's a main role actually. So end user can be two, naive or sophisticated. Okay, so number one, naive users are not aware of the database management system. They are just having simple knowledge about it, and they are not aware of all the functionalities of the database management system. So they they are following the simple steps, okay, and they are entering simple commands and choosing options from a menu, and they are called naive users. They don't need to know anything else about the database management system. Like, for example, here is an example. The checkout assistant at the local supermarket. Sorry. Okay, so we have here, this is just an example, okay? Checkout assistant. In the supermarket, he uses the barcode reader to find the price. Okay? This is just a simple task. And other things will be performed by the system itself. So he can be a naive user because he's just using the barcode to, yes, he don't know how to insert data, how to manage it. He is unaware of all the functionality of the system. He just do some simple, he is performing some simple task, and that's all. So he is a naive user, okay? He is a naive user. Now let's talk about the second kind of people or users or clients, the sophisticated user. The sophisticated user, unlike the naive user, he's familiar of the structure of the database. He's familiar of many functionalities about the database and all mechanisms undertaken by the system or offered or the facilities offered by the database management system. Um, he is using, for example, high-level query language like SQL required by the system. He can write some applications to use it and so on. So he is an expert, kind of expert of the database management system, okay? Like you, for example, as students, you are using SQL in order to build up a database, or you are using SQL in order to retrieve or manipulate data stored in the database. You are not building a database using this, but yes, it's kind of in some stages, not now. You can build up some relations and tables using these simple commands. So you can be counted as sophisticated users, right? Because you are aware of the structure of the database or how to use the database, how to, for example, create your own interface or create your own application. Okay, so this is about the end user or people. So we talked about many kinds of people of the database management system. We start with the database designer or database logical and conceptual designer. We said there are database administrators, data administrator or database administrators, and also we talked about the application designer. Then we talked about clients or end users like naive users and sophisticated users. Okay, as a history of the database system, it started with a file-based system, as we mentioned, then comes the database management system in 1960s. All right, and the first generation was of the database management system was the hierarchical structure. Hierarchical structure, it's like smaller components come together as parts of larger components. Hierarchical means it starts with the first level, then comes the second levels. Okay, hierarchical, let me show you. This is the hierarchical, starting with the first level, then comes, we have here other levels. This is level 2, then comes level, another level here, for example, smaller level. Okay. and we can put like links or associations or relationship among them. Okay, so this is the kind of hierarchical level. So smaller components comes from a bigger. Here are smaller components. They are parts of a larger or bigger components. In the beginning, they used some kind of media, which is called the magnetic tapes, in order to store as a storage device, store the database. Okay, you have heard about magnetic tapes, like the old traditional cassette or VHS tape. It was used to record data on this tape, okay, and it has sequential access. Sequential means we need to go to the first item. Okay, if we want to reach, for example, a point within the tape, we need to start from the beginning in order to find out the point that we are looking for. So this was the first attempt of storing the data. So it was like, yeah, the first generation, it was using the magnetic tape. Then comes the network database management system in the middle of the 1960s. The second generation was we were using the relational database management system, using a kind of we talked about it. Relational means tables representing data in two tables, okay, like this. So this is the relational. Okay, this is the relational. This is the second generation. The first generation was the hierarchical structure. This is number 1. This is number 2. And the third generation is the object relational database management system. It's not defining the data, okay, itself, but it defines the relationship among data and how this data will be represented. So this is number 3. Okay, so this is the history of database management system or the database system. Okay, now let's talk about some advantages of database management systems. Some advantages, it's like, you know, the opposite of the limitations of the file-based system. You remember the limitation of the file-based system? We said separation and isolation of data. We said duplication of data. Okay, so here we have more control over these problems. So in the database management system, there is more control over data redundancy. So this is number 1. There is no need to repeat some sort of data in different instance of the application or data itself, because it's more centralized. It's a centralized system. So the data will be stored only one time in one convenient place, okay, on the storage space, and multiple copies of the same file are not stored. Okay, so there is more control over the data redundancy. Number 2, there is data consistency. Okay, so number 1, control or data redundancy control. Data consistency means data integrity. So any update, all right, will be reflected in all related or linked parts of the database. So, for example, you remember We talked about an employee who is updating his address in the personal application program, but it's not reflected in the payroll system. So the pay slip will be received by a wrong address. And that was a problem in the file-based system, but in the database system, since it's all linked together, it's centralized. Okay, so any update will be reflected in all in the entire system. Any update will be reflected in any application or any departments of the system. So it will be available. The data, updated data, will be available immediately for all users or all authorized users for the system. Okay, so this is the data consistency. All copies of the item are kept consistent at the same time. Number 3, more information from the same amount of data. So there are description about data, or you remember metadata, or and system catalog description, or data about data. So more data will be available for users, and it will be the same amount of data. Okay, so for all users. So all users will be able to access more amount of data, and any additional information will be provided. Number 4, sharing of data. So they will be able to share data with other departments. It will be the same format, all right? So it will be shared to all departments, or with all departments at the same time, because it's not owned by specific departments, it's owned by the entire system. And number 5, improve data integrity. We talked about this, and it's related to data consistency. So it can be expressed in terms of constraints or restrictions of the data. So consistency, the data consistency will be improved, and for example, there will be amount of data which will be hidden from unauthorized users to access it. So this will improve the database integrity. Okay, so no one can violate this or any constraints over the data, and no one which they are not permitted to access an amount of data, they will be not able to display or view this data. So there will be an improved data integrity and consistency. Number 6, improved security. So there will be a security mechanism applied in the database management system. So it will be described and defined in the database management system as an embedded mechanism. So database administrator is able to define security mechanism. Number 7, enforcement of standards. Whether it's organizational or international enforced more in the database management system, it will be following some kind of standards provided or available within the organization itself, or international standards. Number 8, economy of scale. Will be saving cost because it's centralized system, and they will save money, they will save the budget will be there will be a balanced budget, because since it's a centralized system, so there will be no extra costs over, for example, data will not be redundant. There will be no need to having multiple copy or file format, so that will save the cost. there will be balancing in the budget. Also, number 9, there will be balancing in the requirements or the conflict requirements, which means this is the role of database administrators. He can control any conflicting requirements, and they can, for example, they can map the requirements with whatever available in the system. Number 10, improve data accessibility. This is the meaning of having the SQL, can use SQL in order to have ask and ad hoc questions. No need to have a programmer to develop something. The SQL can have yeah, this is unplanned queries. You remember the file-based approach? We talked about something, it was fixed queries. This is not fixed, this is something improved in the database management system. So queries can be unplanned, whatever required by the user, he can just have it as an SQL command, and then the system will be interacted. So number 11, increase productivity. And so ready-made functions and standards, there are ready functions and standards can be used by the user at any time. And improved maintenance. So you can see that all are linked together since it's centralized and since the data is not isolated and separated, okay? Because the data definition is not embedded with the program code. You remember, in the database management system, the data definition is not embedded with the program code. So it's easier to have a maintenance over the data through data independence. We talked about data independence. We said it separates the data description from the application. Okay, this is something. This is the main benefit of having the database management system, because the data definition is not depending on the application program. So any change in the application program is not, or users of the data or the interface is not, they are not aware of any change. So that is the meaning of data independence, or vice versa. If we, for example, have updating the system, the interface, it will not be, or the application program will not be affected, okay? Unless it's linked to something related to that change. We gave example, right? Before we gave an example that if we, for example, have adding a new record, okay, used by the application, this will not affect, or updating the system. If we delete something from the interface and it's linked to the application or to the code, in that case it will be affected. Okay, number 13, increase concurrency. It's managing concurrent database access, which means many users or multiple users can use the database or the system at the same time. So this is something was not allowed, or the users in the file-based approach, for example, they were not able to have multiple access or concurrent access, because one person was using it at a time. Unlike the database management system, multiple users can use it because there is an increased concurrency or concurrency control. Number 14, improved backup. It's possible in the database management system to have a recovery system because it can be automatic. Any failure in the system will take you back to a backup or a point that you can recover the system, the entire system, without losing any file. Okay. Now let's talk about the disadvantages. Still, in the database management system, there are so many disadvantages, and one of these is the complexity. It's a very complicated system, and software is complex as well. The processes, the operations, and any failure, okay, there will be, it will reflect a bad design decision. Okay. And because if it is complex software, okay, some users, for example, will not be able to understand how to deal with the system or the functionality of the system. And there must be a good design decision in order to reduce any complexity of the system. So this is number one, complex system or complex software. Okay, so this is one disadvantage. Number two, size. It requires a large amount of storage space because it's complex, because it's complicated and has or requires many operations. It's the size is very big. The file size is very big or large software. Okay, so this is number two, disadvantage of the database management system. Number three, cost. If we talk about the personal database, it will cost $100. But if we are using a multi-user database management system, from $100K to $1 million. So it costs, the cost is very high. Okay, so this is number three. So one, complex system or software, big size or large software. Number three, cost. Number four, also additional hardware cost. It might require more devices to be used by the database manager system, like a server, for example. It requires servers. It requires storage space requirement. Okay, so additional hardware costs also. This is one of the disadvantages. Again, about the cost of conversion. In order to convert an old system or database system to or existing application to work to a new database management system. So if we want to convert an old system to a database management system, this will cost much more. And for example, cost of training staff, cost of employment new specialists, cost of having more or modern database technology. All these are costs. So converting an old system to a new system will have is very expensive. Okay, high expenses. And another one is performance. And so sometimes the performance of the database management system is not running fast as expected. Okay, so the performance will be affected with the network. It might not run properly, for example. Okay, so many applications depends on many factors. So the performance will be affected. And number seven, higher impact of a failure, which means because of the centralization. Okay, sometimes if the system, the entire system is down, for example, all linked departments will be affected, and they will say system down. Sometimes it happens at the University of Bahrain, right? If there are more traffic, data traffic on the system is not working properly because it's centralized. All right. So if there is any failure in the server, all linked applications will be affected. So that was all for this chapter slide. Do you have any question? As a recap, we talked about as a recap, we talked about in this chapter slide, we talked about common uses of database system. Then we talked about the file-based system, and we said it's, yeah, we defined the database. We said, what does this mean? We defined database management system, database application, and database system as a whole. So we said database system is a collection of application programs interacting with the database along with the database management system. The database is a collection of logically related data. The database management system is the software that's used to manage and control access to the database, while the database application is a program that interacts with the database and links the database with the end user. Okay, we talked about database application. In our daily life, there are so many applications or examples using the database. We talked about the file-based system. We said it's every department deals with its own files, and there are so many limitations. Okay, like separation and isolation of data. Comparing with the database management system, it's very complicated. The database management system is very complicated. This is simpler. There is so many duplicated data because of the isolation and separation of data. Data dependence. The data definition is depending on the application code, and there is incompatible file formats and fixed queries. Okay, then we talked about the database. We defined the element of the database. What is the logically related data? We said it's entity, and there are so many attributes for each entity. Then there are relationships among entities. We talked about database management system through to database language, which are DDL and DML. DDL used to specify the data type and constraints in the structure. DML is used to manipulate data or insert, delete, and modify the data. Okay, then we talked about views, the benefits of having views for each user, and we talked about the components of the database management system environments, hardware, back-end and front-end software, which is database management system, operating system, application program, then data, any data kind of like the schema. Structure of the database is called a schema. Procedures, we'll give example about it. Then we talked about people, database administrator, data administrator, database administrator, and logical database designer, physical database designer, application developer, and users, naive and sophisticated. Okay, then we talked about advantages of database management system, and then we end up this chapter slide with disadvantages. Do you have any questions? I'm gonna provide you a link. Okay, we will have some activities related to this chapter slide, since there are so many information here. Okay, great. I will have it like an activity. I will have this revision. It's like a revision. I will have it like an activity, so you can refer to it whenever you want to refresh your mind about this information covered in this chapter slide. So, okay, so no questions. Thank you so much for attending today. Inshallah, see you next time. Next time we are going to start chapter number 2. You're welcome. Yalla, see you next time. You can leave. You're welcome. Take care of yourself. Bye bye.